Good afternoon, students. Good afternoon. I take immense pleasure in demonstrating this simulator. It is an IoT-based simulator. So the name of the simulator is Koja. Okay. It is Contiki object-oriented Java simulator. Okay, so in the front end, Java code will run to visualize the nodes we are using in the application, and at the back end, C code will be running. Okay, you might have heard about the term IoT. What is IoT? Internet of Things. That is, conventional internet is meant for exchanging the files between the humans. Okay, clear? We are exchanging the files through the internet with the help of the hardware and the software development tools we are having in the commercial market. Okay, clear? So what is the medium we are using for exchanging the files through the internet? What is the medium we are using? In computer network subjects, you might have learned about the OSI layer model. What is OSI layer? What is OSI layer model? 7-layer model we are having now. What is that? Why we are calling that model as open system interconnecting model? Open System Interface is abbreviated as OSI. Clear? So what is the meaning for that? What is the meaning for that? The system is open. That is, without knowing the underlying hardware between various systems, we are exchanging the files between the systems. Okay, we are exchanging the file from a mobile phone to laptop to desktop, and desktop to printers, desktop to displays, keyboard to computers. Okay, clear? Pranamalia. Correct? So for that, what is the medium we are using? Both wired as well as wireless medium. So under wired medium, predominantly we are using USB ports for connecting the keyboard, mouse, printers to the desktop computers. Okay. And from one computer to another computer, how we are connecting? What is the interface we are using? What is the physical medium we are using for connecting two computers? Ethernet cable. That is RJ45 cable, which is developed by International Telecommunication Union for connecting two systems at various places. Okay, so already backbone infrastructure is being developed by the telephone industry for connecting two systems serially all over the world. Okay, clear? So RJ45 cable, the telephone department might have kept the intermediate boosters for boosting the signal. There is so for connecting two systems, two computers at various places, we are using the physical interface called RJ45. Okay, that is the wired medium we are using for connecting two systems, two computers. Okay, and through wireless also we are connecting two systems. Even our mobile phones are based on wireless. Okay, nowadays in our home, even we are connecting so many devices with the help of a technology called Wi-Fi. Okay, so Wi-Fi, WiMAX, Bluetooth, Zigbee, Z-Wave, these are the various wireless technologies we are having for connecting two systems wirelessly. Okay, and USB, Ethernet, serial ports and parallel ports. With the help of that, we are connecting different systems through wired means. Okay, so both wired means as well as wireless means, we are connecting two systems for exchanging the files between the systems. Okay, clear? So that is called nothing but it is a network connecting two or more systems in order to establish the communication as well as in order to exchange the files between the systems, which is called computer networks. Okay, this presentation is meant for the nodes which is going to communicate wirelessly for a targeted application. Okay, so the targeted application can be home automation, automated monitoring and control applications in advanced home automation, and it can be the application which is targeting healthcare informatics, where we can do patient diagnosis and remote medication. Even for military applications also, for performing the battlefield surveillance and monitoring, we can use this IoT based simulator, and we can use the simulator for monitoring the automated time critical applications like industrial process control also can be wirelessly communicated between various systems. Okay, so these are the targeted applications we can perform with the help of this Koja simulator. Okay, so the simulator name is Contiki Object Oriented Java Simulator, Koja simulator. Okay, so we are going to see the demonstration of this simulator now. So this simulator actually it will be running in the virtual machine. Okay, in the virtual machine. So you have to install the virtual machine in your system. So this simulator will run in the Ubuntu operating system. So this is the package actually we have to download from the Instant Contiki website. So the name of the package is Instant Contiki 2.7 is the package now, package name. And newer versions are also available. Instant Contiki 3.0 is available, and Instant Contiki next generation wireless networks is also available. You can download it from the corresponding websites, and you have to give the username as user. User is the password you have to enter in the environment. And this is the simulator environment. Okay. So in this simulator we are having an inbuilt package called Wireshark. Wireshark analyzer is there. So we can do the analysis, packet tracing analysis. That is, what are the data we are exchanging between the nodes that can be viewed with the help of this analyzer, Wireshark analyzer. Okay, it is a freely inbuilt analyzer available in this Contiki package. So even if you want more features, you can get licensed softwares. Licensed analyzers are also available that can be used for hacking application. Okay. So this is the simulator icon. So if you click that simulator icon, the simulator will start running. So in this, first you have to create a new simulation. And you can give the name of the simulation as anything. So I have given a name, ECA demonstration. So if you open that, so many windows are now getting open. So this is the network window. This window is called network window. This is the network window where you have to deploy the sensor nodes. Okay. So the inbuilt nodes supported by this Contiki simulator is, these are the nodes supported by this simulator. So we are having a Mica mode and Puja mode, and this is Ethernet mode, and this is Texas Instruments mode, and this is EXP 2420, EXP 1101, and CC 430, and this is Sky mode, and this is Wise mode, this is Zolarsia mode, Z1 mode is Zolarsia mode, and this is ESB mode. ESB, actually you might have heard about the terms like Arduino and Raspberry Pi. Even now school students are doing Arduino based projects. Okay. So for Arduino, they have given a separate simulator for that. Even Arduino based Wi-Fi modes can be simulated in this environment. Okay. Clear? What is Arduino actually? Have you heard about the term Node MCU? Node MCU. What is that? Arduino. What is the purpose of Arduino development boards? Any one of you? What is Arduino actually? Arduino, Raspberry Pi, Orange Pi, Apple Pi. We are having variety of open source hardwares. What is the purpose of that development boards? Any idea? Arduino development board we are having, what is the purpose? Even school students are doing some of the projects. Even you can drive a car, toy car. Toy car hardly we are having one or two motors. One motor is driving the vehicle at the front and back. Another motor can drive the vehicle in either right side or left side. So that kind of small application can be run with the help of Arduino. Okay. But in Arduino, we are not having inbuilt Wi-Fi or inbuilt Bluetooth capability. Whereas in Node MCU, apart from the microcontroller, we are having inbuilt Wi-Fi also. So we can connect the ESP node with the help of Wi-Fi. Okay, clear? In Wi-Fi, in mobile phone, we are connecting two devices, we are connecting more number of devices for playing the games. For network games, we are using the edge application, edge computing application. Correct? Yeah. We are having Node MCU, a hardware like Node MCU, where we are having microcontroller and many digital IOs, as well as one analog IO can be handled with the help of Node MCU. So in that we are having inbuilt Wi-Fi also. So with the help of Wi-Fi, we can wirelessly connect the different nodes. Okay. So that node, actually if you say a node which is having 5 important submodules. One submodule is sensing module, which senses the parameter, and the second submodule is processing module, which processes the sensed information, and there is a communication module, there is a radio module, which can be used for exchanging the files or exchanging the data between two nodes. Okay, and there is a power supply submodule that will give power supply to all the nodes, and there is a control submodule which provide control, on-off control, PI control, PID control to the nodes. Okay, so if you purchase some 300 rupees Node MCU development board, you can use the development board for controlling the various electrical appliances in your home. Okay, even lights, fans, fridge, washing machine, TV, even your car garage door open and closing can be controlled with the help of the Node MCU hardware. Okay, that means you can design your own IoT based application with the help of low cost hardware device available. Okay, so now I am going to give the simulation demonstration. So among all the nodes, sensor nodes available, you can use Sky mode for all the application. Okay, Sky mode is the default mode we can use for designing all the applications. So if you browse, you can port the program inside the nodes. So I am going to port the collector example. Actually, there is an example called collect. We can port that C file into the hardware, and you can compile it. When you are compiling, it has to generate the object file as an output. Okay, if there is any error message, you have to overcome the errors, and after that you can create the nodes. Okay, this is the procedure. So now we can create the number of nodes. Say for example, now I am going to create some 25 number of nodes, and the type of positioning I can use this either random positioning or linear positioning. What is actually random positioning and linear positioning? What are the type of topology we can connect the devices? Any idea? Type of topology. Bus star, mesh, grid, random, ring, hybrid topology. We are having variety of topology, no? So like that we can deploy the nodes. Okay, star topology, mesh topology, bus topology, random topology, grid topology. Actually, random topology means the application where we require, we have to deploy the nodes, throw the nodes from anywhere, and that can be randomly deployed in many places. Okay, say for example, for weather monitoring, we have to throw the nodes from the helicopter or drones. Okay, randomly we can throw the nodes. The thrown nodes will be sensing the information and it will send to the centralized controller. Okay, clear? So now I am going to deploy the nodes in linear positioning. Linear, there will be a equal distance between the nodes. Okay, clear? See the applications like street light control, where the applications like battlefield surveillance, and the applications like cricket stadium, where the shape will be in oval. We can deploy the nodes like oval shape. Okay, so the linear is a type of topology. We can deploy the nodes. See how there is an equal distance between the nodes. Okay, can you see that? Actually, in the view mode, you can assign the address. Actually, coming to address, either it can be local address or it can be IPv4 or IPv6 address. Okay, so in IPv4 we are having 32-bit addressing scheme, whereas in IPv6 we are having 128-bit addressing scheme. Okay, so if we say address, in computer networks we are using three types of addresses. IP address, which is meant for finding out the location of the device. Okay, IP address. IP address, MAC address. MAC address is the physical address of the device. Okay, and port address is the address of the application. Okay, so we are having three important address schemes in the computer networks. So IP address will identify the location of the device, and MAC address will identify the physical location of the device, and the port address will identify the application which is running on the device. Okay, in computer we can run so many applications. So to which application I am communicating that we are exchanging the files again is important. Okay, so for that I need three addresses. So this is IP address. So if you click this button, and IP address will be assigned, and there is an LED in the nodes. We are having three LEDs like red, green and blue LEDs are available in all the nodes. And radio traffic, we can find out the radio traffic, and we can find out the positions, and we can find out the background grid lines, and the type of mode. If you have different type of nodes can be identified with the help of different color mechanisms. Okay, so now I have created 25 number of nodes, which is collecting the information from all the nodes. Okay, So I have told you now, if you say a sensor node, we are having 5 important submodules. What are they? Sensing module, processing module, communication module, control and power supply module. We are having 5 important submodule in one sensor node. Okay. So if you start the simulation now, actually this is the network window and this is the simulation control window where we can start and stop the simulation, and this is the mode output window. So inside that we can find out what are the data exchanged between the nodes, and this is the timeline window where it shows at what time the radio is on, radio is off, and when it is transmitting the data, when it is receiving the data, and when it is in idle state, the radio, what are the status everything we can find out in the timeline. Okay, now I am starting the simulation. See, I am starting the simulation. Now the nodes are start communicating with each other. Can you see the radio messages? Actually, this is the network window. This is the network window. You can maximize all the windows. Okay. So the RMR shows the 5 data exchange between the nodes. Okay. So the type of medium what we are using is wireless. So if you click a particular node, the coverage range of the particular node will get displayed. Okay, coverage range. What do you mean by coverage range? If you have a mobile phone, when you make a call to another person, if there is any error message, if the targeted person is not in the coverage range, you will get the error message like the receiver is not in the coverage range, you will get error message. That error messages are received with the help of a term called RSSI, that is received signal strength indicator. Okay, so if you have a sensor node, you are having coverage range for the sensor node. So this green circle shows the complete coverage range of the node, and the gray part is showing the interference range. Okay, partial coverage range, and the white part is nothing but no coverage range. Okay, so there are 3 regions. Green region shows complete coverage range, 100% coverage range, and the gray region shows partial coverage range. Okay, so when the node is in partial coverage range, you may not be having good connectivity between the nodes. Okay, there will be a drop off in the call, and if there is no coverage, you cannot communicate from one node to the another node. Okay, so when you click any node, that node's coverage will be displayed. Okay, and even you can change the interference range and the transmission range. See, now I can change the coverage range of the device. Can you see that? The green is getting expanding, Can you see that? So I can change the transmission range, I can change the interference range, even gray also can be varied. Can you see that? But for all the nodes, the coverage will be same. Okay, so the green indicates complete coverage range, and the gray indicates partial coverage range, and the white indicates no coverage range. Okay, so now this simulation is being running at least for 5 minutes. Now I can find out the correct view. See, I have told you about 5 important modules we are having. I have told you about 5 important modules. என்ன சொல்லிருக்கேன்? We are having sensing part, processing part, communication part, control part, and power supply part. Okay, so for sensing the node, how much power will be taken by the node, அதை ஐடென்டிஃபை பண்ணலாம். அதே மாதிரி for processing, how much power is being consumed by the node அப்படின்றத I can analyze. And for communication, to communicate between one node to the another node, how much power it is taking அப்படின்றத I can analyze with the help of the collect view. Actually, as a computer science engineer, you must write the C code for your targeted application. Okay, this application actually targeting the power consumed by the nodes. So there is a tool called mode radio duty cycle, where you can find out when the node is transmitting, how much power it is taking while transmitting, while receiving how much power it is taking. This is radio transmission power. Radio transmission power. Can you see that? It is not clear. So, how much power the radio it takes while transmitting the data, and how much power the radio is taking when receiving the data, and how much percentage the radio is turning on. We can find out with the help of this window. Okay, and another tool is there is a collect view tool, and we can click in any node for analyzing the power consumed by the nodes. So there is a command called send command to the node, and for start collecting. Okay, so let it run for 1 or 2 minutes, so that we can find out the analysis. How much power it is taking for sensing, how much power it is taking for processing, and how much power it is taking for communication, and how much power it is taking for control. We can analyze. See, there is a window called power. So if you click that, you can maximize this window. So can you see that? What are the various color represents? Actually, there is a nomenclature at the bottom. What red color shows? Red color enna potrudhu? LPM. LPM is nothing but low power mode. When the node is in low power mode, how much power it takes from the total power? How much power it takes for sensing? For sensing the information, how much power the sensor node takes. And the blue color is power consumed by the CPU. That is for processing the sensed information, how much power the CPU takes. It is represented in the blue color, and the green color represents when the radio is listening. When the radio is listening the medium, how much power it is consuming. It is represented in the green color, and the yellow color, which is nothing but for a transmission, how much power the node takes. Represented by the yellow color. Okay, clear? So based on this information, you can find out the lifetime of the node. Okay, so if you deploy the nodes randomly for a targeted application, you can predict the lifetime of the node, so that you can decide when we can replace the batteries available in the nodes. Okay, because all these devices are battery operated devices. Okay, so the power consumed by the nodes, we have to consider it as very precious resource. Okay, clear? So see this window. In this window, we can see what are the protocols, various protocols running at the background of this sensor node. That is, the physical layer, what is the protocol running? In the data link layer, what is the protocol it is running? And in the network layer, what is the protocol it is running? And then transport, session, presentation, application. We are having 7 layers, OSI. OSI stands for, already I have told you, Open System Interconnect Module. That is, without knowing the underlying hardware and the software running between the two systems, we are exchanging the files. Okay, so the system is open to exchange the files between two computing devices. Okay, no need to be a computer. It can be a mobile phone, it can be a laptop, or it can be a desktop, or it can be a PDA. Okay, it can be any device which is based on IPv6 enabled devices. Okay, so that devices we are calling it as 6 low band devices. IPv6 enabled low power personal area network devices. Okay, so all these devices are coming under ISM band. Okay, there is a application called industry scientific medical application. You no need to get license for developing that nodes. Okay, clear? See, for utilizing the frequency band for mobile phones, the cell phone providers, service provider has to get the license from the government for utilizing that band of frequency. Okay, actually mobile phones are using 900 megahertz frequency band, and these devices, 6 low band devices, uses 2.4 gigahertz or 2.4 to 5 gigahertz frequency band. Okay, so these frequency bands can be used for developing industry, scientific and medical applications. Okay, so this window represents what are the protocols running at the background of this window, and what is the information exchange between the various nodes. We can find out with the help of this window. Okay. So coming to MAC protocol, medium access control protocol, we are using CSMA Contiki MAC. Actually, in MAC, the second layer is called data link layer, which is divided into logical link control and a medium access control. Okay, so the type of medium access control protocol we are using in the node is CSMA Contiki MAC. And the routing protocol is the RIME protocol. Okay. And even if you want to know what are the data exchanged between the nodes, that can be identified with the help of radio messages. Initially, I have told you about the Wireshark analyzer, Wireshark, packet tracer. So, what are the packets exchanged between the nodes that can be identified with the help of this window? Okay. Even hackers will use this information for hacking a particular device in the network. See, I can trace, this is actually a from node and this is to node. From node 7 to node 4 at a particular time there is a packet exchange, and what is the packet exchange in the I can trace out. Okay. So I can store this information in one of the Excel file for analyzing the information. Okay. So yeah, I can run the simulation for 2 days. When the